Integral calculus is a very common topic which you would be studying either in engineering mathematics or in degree mathematics. So here in this lecture, let us solve a few problems related to double integrals. Problem 1. So this is the first problem. So you have double integral x square y dy dx. So definitely this happens to be y varying from 3 to 5, which corresponds to dy, and x varying from 1 to 4. Let me first integrate x square y with respect to y. So when I integrate x square y with respect to y, treating x square as a constant, so we have x square integral 3 to 5 y dy, and then you have dx integral 1 to 4. Now what is integral of y? Integral of y is y square by 2. For y varying from 3 to 5, and then you have x square with the limits varying from 1 to 4 dx. So substitute the limits for y square. So you have integral 1 to 4 x square. Observe y square. You put y equal to 5, so you get y square is 25 by 2 minus y equal to 3. So 3 square is 9 by 2 dx. So what do we have? 25 minus 9 divided by 2, which is 16 by 2. So I have integral 1 to 4 x square into 16 by 2 dx. So this is 8. So take 8 outside. So you have 8 into integral 1 to 4 x square dx. Integral x square is x cube by 3 with the limits varying from 1 to 4. So substitute x equal to 4. So I have 8 into 4 cube. So I can take this 3 outside the brackets. 4 cube minus 1 cube. Right? So 4 cube is 64. So you have 8 by 3 into 64 minus 1, which is 8 into 63 by 3. So I have 3 2s are 6, 3 1s are 3. So you get 21 into 8. So 21 into 8 is 168. So that's the answer. Problem 2. R sine theta dr d theta, where r is varying from 0 to cos theta, and of course theta varying from 0 to pi. So since we are first integrating with respect to r, sine theta can be taken outside because it can be considered as a constant. So I have 0 to pi, and then you have, I take sine theta outside, and then you have integral r varying from 0 to cos theta, r dr d theta. So integral r with respect to dr is r square by 2. So you have r square by 2 with r varying from 0 to cos theta, and then you have d theta integral 0 to pi sine theta. So wherever r is there, you put cos theta first. So you have integral 0 to pi sine theta, and you have cos square theta by 2 minus 0 by 2 d theta. So this is nothing but cos square by 2. So I can take 2 outside the bracket, 2 outside the integral. So 1 by 2, 0 to pi, you have sine theta cos square theta d theta. Now how do I proceed with the integration? So you have sine theta and then you have cos square theta. So here we have to do substitution. So put cos theta equals t. So differential of cos theta is minus sine theta. Therefore minus sine theta d theta equals dt. So what is sine theta d theta? Sine theta d theta is nothing but minus dt. Now here theta varies from 0 to pi, right? So as theta varies from 0 to pi, so theta is varying from 0 to pi, what happens to t? So when theta equals 0, cos 0 is 1. So t is 1. When theta becomes equal to pi, then what happens? Cos pi is nothing but cos 180 degrees, which is minus 1. So therefore t varies from 1 to minus 1. So what is 0 to pi becomes 1 to minus 1. So observe, you have 1 by 2, the integral now becomes 1 to minus 1. All right, and then you have sine theta d theta. Sine theta d theta is nothing but minus dt. So let me take minus sign outside. It is dt, and then you have cos square theta. Now what is cos theta? It is t, so you get t square. Very simple. So you have minus 1 by 2 integral t square. So our integral t square is nothing but t cube by 3 with the limits varying from 1 to minus 1. So this is minus half. You have minus 1 the whole cube by 3 minus 1 the whole cube by 3. So you get minus half. So minus 1 cube is minus, and here also you have minus. So you have minus 1 by 3 minus 1 by 3, which is minus half into, so this is minus 2 by 3. So minus minus gets cancelled, 2 and 2 gets cancelled, so the value is 1 by 3. A very simple problem. The next one is a very interesting problem. Evaluate the integral x square plus y square dx dy, where r, which is the double integral, is nothing but a triangle which is bounded by the lines y equal to 0 and y equals x and x equals 1. So let us see what these lines are and how do we get the triangle. So this is x-axis and y-axis. Y equals x is this line, a line which is inclined at an angle 45 degrees, and then y equal to 0. Y equal to 0 is nothing but the x-axis. So this is one line of the triangle. This is the other line. So this is y equal to 0 line, because all the points of the x-axis will have the y value 0. And this is y equal to x. Let me write it here. And then x equal to 1. What is x equal to 1? I have a point here where x is equal to 1 and y equals 0. So if I draw a line which is parallel to the y-axis passing through the point 1 comma 0, I get x equal to 1. So this line is x equal to 1. So observe, I have a triangle here. Let this triangle be A, B and C. And what are the points? At B it is nothing but origin. B is the origin. Point C is 1 comma 0 and point A is 1 comma 1. So observe here, x is varying. X is varying from 0 to 1. Right? X is varying from 0 to 1. Whereas y, how is y varying? There is an inclination, there is a line like this. So y is varying from 0. At this point y is 0. So this is the line y equals mx, isn't it? So at this point y is 0, and then all along this line, how is y varying? It is varying such that it is equal to x. So x varies from 0 to 1, whereas y varies from 0 to x. So this is something which you need to remember. So here we have x varying from 0 to 1 and y varying from 0 to x. So y varies from 0 to x, whereas x varies from 0 to 1, x square plus y square dx dy. Now observe here, y varies from 0 to x. So if I first integrate x and then if I integrate this term by y, I will have x remaining. So now let me interchange them. So I have integral x varying from 0 to 1, y varying from 0 to x, x square plus y square dy dx. So now I integrate this term with respect to y, treating x as a constant. So here you have x equal to 0 to 1. So if I integrate this with respect to y, I get x square y plus y cube by 3. And what about the limits? 0 to x dx. So wherever y is there, I need to put x. So this is nothing but x varying from 0 to 1. Wherever y is there, put x. So you get x cube plus x cube by 3 minus 0. So I will avoid it, dx. So you have x cube plus x cube by 3 dx. So if I take the LCM, I get x varying from 0 to 1. So this is 3x cube plus x cube by 3 dx, which is 4 x cube by 3. Okay, so let me take this outside. 4 by 3, I take it outside the integral. So it is 4 by 3 x cube dx, where x varies from 0 to 1. So now I integrate this. So you get 4 by 3. Integral of x cube is x power 4 by 4 with the limit 0 to 1. So you get 4 by 3 into 1 minus 0 by 4. So 4 and 4 gets cancelled. So the answer is 1 by 3. So very simple problem. So the next problem, find the area of xy dx dy, where A is the area bounded by the circle x square plus y square equals a square in the first quadrant. So let us consider the circle. So x square plus y square equals a square is a circle with center as the origin and the radius as a. So this is the circle, and this point is a comma 0, and this is 0 comma 0, and I need to find the area along the first quadrant. So this is the x-axis and this is the y-axis. So observe, x is varying from 0 to a. So x varies from 0 to a. And what about y? I have x square plus y square equals a square, whereas y square equals a square minus x square, and y equals plus or minus root of a square minus x square. Now, since we need to find the area only in the first quadrant, the value of y is positive. So therefore, y varies from, so at this point y is 0 here, and I move along the circumference of the circle. So y varies from 0 to root of a square minus x square. So x varies from 0 to a, whereas y varies from 0 to root of a square minus x square. So this is nothing but equal to, you have xy. Y varies from 0 to root of a square minus x square, whereas x varies from 0 to a. So this is x varying from 0 to a and y varying from 0 to root of a square minus x square. So first let me integrate the expression with respect to y, keeping x as a constant. So I have integral xy dy. So you get x into y square by 2 with the limits 0, root of a square minus x square, and then integral x varying from 0 to a dx. So next, what is the next step? X varying from 0 to a. So wherever y is there, put root of a square minus x square. So you have x into y is root of a square minus x square, the whole square by 2 minus 0. And then you have dx. So this is under root the whole square. So you get integral x varying from 0 to a, x into a square minus x square by 2 dx. So this is nothing but integral x varying from 0 to a, x a square minus x cube 1 by 2 dx. So now integrate this with respect to x, very easy. So you get 1 by 2. So I'm integrating this with respect to x. So you get a square x square by 2 minus integral x cube with respect to x is x power 4 by 4, and the limits of x varying from 0 to a. So what do you get? 1 by 2 into, so wherever x is there, put a. So a square into a square by 2 is a square 4 by 2 minus, put x equal to a. So you again get a square by 4 minus 0. So the other term is 0 here. So now let me take the LCM. A power 4 by 2 is nothing but half. So it is half into a power 4 minus 1 by 4 into a power 4. So this is nothing but 1 by 2 into a power 4. So this is half minus a quarter. What is half minus 1 by 4? It is 1 by 4. So you get 1 by 2 into a power 4 into 1 by 4. So the answer is a power 4 by 8. Problems related to double integrals. So in the next video segment, we shall see how to solve the problems where you need to change the order of integration. So it may be double integral. So how do we change the order of integration so that the process of integration becomes much more simpler, and then we'll move on to triple integrals. So do not forget to like, share and subscribe, and press the bell icon to get notifications of all the further uploads, and thanks for watching.